chassis out there, you can see some of the guts, which to engineers is really the beautiful part, the part that's underneath. And we learned how to do aluminum structures pretty well on the 7th generation, and we took everything we learned and made it even better on the 8th generation. The new car is fabricated in an entirely new body shop in Bowling Green. So if you go over there, you'll see the whole C7 body shop and a whole C8 body shop kind of side by side. So it was a big investment for us to create a unique in the world mid-engine, good luggage room, open air architecture. That's a solution that we've been working on for a long time, making all those things happen. And it required a lot of new technology. If you look at the construction of this thing, you'll see that there's what we call high pressure die castings. There's 6 gigantic castings. They're about 4 feet long, and they make up the most complicated parts of the structure. So if you look at every place you see where there's ribs and things, so this whole corner all the way down here, that's one casting on both sides. And the same thing from here all the way up through the shock towers, all the way back here. It's also high pressure die casting. Then there's cradles underneath, you can't see the one on the back, that also have these massive high pressure die castings. We use that because high pressure die casting is the best way to form aluminum in the world. You power the aluminum into the mold, and so you don't get porosity. You get really good material properties, and you can cast parts with very thin walls and do very thin ribs, which is very mass efficient. You take all these complicated interfaces and you can put them all in one part, and that's a real winner. Not having all those joints is a real win for body structure integrity. When we went to go find a company to make this, because General Motors doesn't do a ton of casting, especially high pressure die casting, we found there was nobody in the world willing to do this size, this quantity, and this quality of casting for Corvettes. There just wasn't anybody. And so we had to do it ourselves. We had to go back to General Motors leadership and say, we got to learn how to do this. And so we actually went back and appropriated, did a business case for it, went back and appropriated money, and built out our Bedford, Indiana plant, put in a new assembly area. It's a plant where they cast blocks and heads. It's not the exact same kind of process, but at least they're somewhat familiar with casting. So we actually brought this, we insourced this, so that we could build the volume we wanted of this kind of technology. And it's a huge enabler to make this whole body structure work. So it's amazing we've gotten this far. We really haven't talked about that engine very much. I'm amazed that we got away with it. Everybody knows the headlines: 495 horsepower, 470 foot-pounds of torque, 0 to 60 under 3 seconds, top speed 194 miles an hour. So I said it at the reveal at a time when the whole rest of the world is going to small displacement, charged engines. We're bucking the trend and staying with the small block V8. It's a huge competitive advantage for us. It's a very compact engine. It's very light for the power it puts out. Having that engine compactness helped us with the body structure because we could make load pass around the engine, and having it small made those very, very efficient. So the architecture in return helped out the engine. So putting the engine in the back makes the breathing a lot more effective. So when the engine's in the front, the throttle's on the front, and it has to breathe cool air, and you have this big radiator forward of it that goes right up to the hood. And so that's why you see these snorkel arrangements we've had that either get really thin and wide, reach over the top of the radiator, or on C7, you take a turn and you go out to behind the headlamp. And it's a very compressed space up there, and so it's very difficult to get low restriction intake systems. The same thing on the exhaust. When the engine is in the front, you take the exhaust out the manifolds, and it has to get down to the center tunnel, and there's a pinch point because we've got the engine shoved rearward as far as we can, right up against the front of dash, and then trying to snake exhaust through where your pedal box is, the throttle and everything. And you got to get into the tunnel. There's a pinch point there between the block and the body structure and where the passengers need to be. And you actually have to compress the exhaust. You dent the pipes, and it's a very restrictive area in the car. When you put the engine in the back, if you've seen the engine out there, we've got these like really cool short headers that come out over the top, and they can go down under the luggage compartment. There's no pinch point. And so both on the intake side and the exhaust side, we have very low restriction on this. So we're able to take advantage of that with the cam timing to get a very free-breathing engine that pulls very hard all the way to redline, puts the power peak up at 495 horsepower. So that's a way that the car's architecture helps the engine guys perform better. So we also have a DCT. I don't remember, do I have to line on the DCT? No. Okay, but I do want to talk about this. We haven't talked about this much. You'll see some of the cars out there. We go to Corvette shows all over, and we know how much people like to customize their car. A lot of the hoods are up at shows, and people have done things to make their engine and their engine compartment more beautiful. And so we said, well, why not do that from the factory? And so we've got these very large vented carbon panels to close out either side of the engine compartment, and then we mounted, so this is additional lighting. So when you open the hatch, the lights in the luggage light up, but when you get this option, you get the carbon panels plus additional lights that are mounted to the underside of the hatch. So when you open up, the whole engine bay is all lit up, bathed in light. And then as you approach the car and you turn, you lock it or unlock it, and all the courtesy lights come on, it lights up too. And so as you approach your car, you can actually see the engine kind of glowing in there. It's a really cool option. It hasn't got a ton of airplay, but you can go out and check it out on some of the cars out here. So Z51. We've had Z51 for decades and decades. We have it, it's a little bit different this time, but it is essentially, if you're going to track your car, it's a must-have option. Harlan didn't mention it, when he was going through all the standard equipment, one of the things we did was make dry sump standard. And we've been working on dry sump for a long time. Making it standard let us mount the engine lower in the chassis. It's about an inch lower than on today's car. And so even if you get the standard car, you get the advantage of the dry sump. You get that nice low engine, lower center of gravity. And because we made it standard, all engines have the dry sump, so we didn't have to do a version with and without. And so we're able to integrate the content for the dry sump into the base engine. So instead of one scavenge pump, we have 3. So traditional one coming out of the sump under the engine, but we also have 2 in the heads. And you might think, well, why do I need to pump oil out of the heads? It's just going to run back down into the sump anyway. But on a 90-degree V8, each of the banks of cylinders is sitting at an angle of 45 degrees to the ground. When you're cornering at 1G, you have a lateral force of 1G and a downward force of 1G. And the net result is a 45-degree angle. So the oil inside the engine doesn't want to flow up and it doesn't want to flow down. But when you're cornering at 1G, the body rolls a little bit, and actually the engine inside the body rolls a little bit. So the engine is actually laying more than 45 degrees, so the oil doesn't go down, it runs up. So when you're cornering hard, it's actually the engine oil wants to go up into the valve covers, and that's why you have sumps on either side to take that oil out, plumb it, cool it, deaerate it, and feed it back to the engine, so the engine always has nice, cool oil with no air in it. So we made that standard, but there's still lots of content in Z51. You get the summer performance tires. We haven't talked about the all-season tires, but you do get track-oriented summer tires. You get FE3 performance suspension, adjustable threaded spring seats. It's kind of a racy thing. Somebody was asking me the other day how you adjust the height of the car. You can put FE4, magnetic ride control, on top of that. And this isn't just the same MR that we've had previously. This is a 4th generation. We were pioneers in this technology way back when. Now we're on to the 4th generation. And the big deal with this is that we actually put accelerometers on the knuckle. So right out where the tires drive loads into the body, we put accelerometers on the knuckle. And that lets us read what's happening at the wheel much quicker. You take advantage of that with our new electrical architecture, which transmits messaging 4 times as fast, and we can really perceive what's happening out at the tire, and then we have software that can take advantage of this. It's the best riding suspension we've ever had. Of course, you get bigger brakes, you get extra cooling. The cooling's really cool. You got the 2 radiators up front that Kirk was talking about, and when you get Z51, when the coolant comes back, we actually cool it again. We have a heat exchanger inside the big quarter panel opening to kind of super cool the coolant, and then we use that to cool the lube for the trans and the oil for the engine, keeping all those temps very low. So that comes with Z51. ELSD. So we've had ELSD as part of Z51 since last generation. This time it's part of the DCT, so it's integrated into the transaxle. Since we have 60% of the weight on the rear wheels, it makes it more effective than ever. It's a huge enabler for us to do dynamic vehicle control. It makes the car really, really benign to handle. This car is so easy to learn how to drive at the limit. It's incredible. So Kirk talked a little bit about the aero, 400 pounds of downforce at 180 miles an hour. The car actually goes faster than that, so there actually would be a little more downforce at top speed. But again, this is the first time we've had a Stingray with real full vehicle downforce. Great cooling, and then also includes NPP. Everybody likes NPP. It really gives you the sound quality, the tunability, the adjustability, customizability that everybody likes. You can have it very quiet, or you can have that ground-pounding American thunder that you guys all like.
Where's the third radiator?
Third radiator is in the quarter ducts. So you see those big ducts in the back? The third one is actually, we have power fans on both sides, but you get a radiator in addition to that on Z51. And here's a picture showing some of those cooling paths. You can see the cool air going in. You can see the radiator. I think Kirk covered most of this. But that blue air going in, that goes into that heat exchanger. So this is a little complicated, but I want to talk about this a little bit. It's really, I was talking about how low restriction the intake is. So the air going through the top of the opening, so you can kind of see it up here. This is a view kind of low looking. We've got the skin peeled off. Here's the rear brakes. You can see there's a flow path here. That's actually the air going into the engine. So if you look at it as you're looking at it from the top, here's those same blue lines. They come into the top part of that quarter opening, and they actually flow through passages we created out of the body panels that need to be there anyway, the structural body panels. So there's no separate duct. It's just the panels that go out and support the quarter panel. Creates a very large opening. You can stick your arm right through it. It's so large. It goes behind the engine, takes a turn, goes through a very large air box. The rolling chassis shows this. You can see it very clearly. We have a big kind of old school air filter, a big oval air filter, lots of surface area, so very low restriction. That's positioned on vehicle center line, and that feeds the throttle body on the back of the engine. So that's good in 2 ways. One is it reduces restriction. The other is the sound waves that are created by the engine breathing are actually transmitted back up and out that same opening, so it's just over your shoulder at the rear of the door, and that's a very good sound. That's the kind of engine sound that you want to hear, that strong induction V8 sound. And so that's a way we actually can create a noise path intentionally back to the occupant that you can hear. Steering. So we've talked a lot about steering. Part of the architecture is the driving experience, less weight on the front wheels, car turns in really quickly, and we didn't talk about the fundamentals, but just sitting this much closer to the front axle shortens the steering. I mean, it almost looks like a ridiculous proportion, but this is the real math of today's car, where you sit and how long the steering column is, intermediate shaft. By the time you get to the rack, you're 1,600 millimeters away, 1.6 meters. You can see we've shortened it substantially, much more direct connection to the steering gear. So that gives you a a very stiff system, and a stiff system means that the second you move the wheel at all, you get a reaction at the front tires and the vehicle starts to move. We also have the tightest turn circle, which we've ever had, because we have an even longer wheelbase than today, even wider track than today, yet the turn circle is tighter, especially if you get MR. And the reason why is that we have a new invention. We use the position sensors that come with MR that tell you where the wheel is in the position relative to the body, and we have a dynamic rack stop. So typically on a rack and pinion, steering, you have a mechanical stop at the end. But on this car, when you get to the end of travel, all it is doing is back driving the motor electronically. It feels like a stop, it feels like a hard stop, but all it is the rack not letting you turn it anymore. And that way we can adjust that stop based on conditions. So typically in vehicle design, you have to design that mechanical stop for the worst case condition, which is typically when you turn the wheel at full lock and you drive in a steep driveway ramp and you're trying to pick the car up by that inside front tire, so you push the wheel all the way up towards the body and you have to make sure that that tire is not going to touch anything. And you have to restrict the travel based on that. But any time the wheel's any other place, you could actually turn farther and it would be okay. So what we're doing is using that position sensor to look at where the wheel is, and in most cases where you're just doing a parking lot maneuver, you can actually let the car turn more sharply. And so a 36-foot turn circle curb to curb for a vehicle of this size and proportion is kind of unique in the world. Okay. So the front lift system, this is the one thing, when we did the reveal, it's this giant space, and it was really hard to hear what the audience reaction was from up on stage, because there was just this giant space. Everybody was so far away and all the sound got lost. But the one thing I did hear is all the hoorays and the applause when we said we were going to do this front lift system. So, you know, Corvettes historically, they're very low cars, low center of gravity. They need very low aerodynamic panels, and so it doesn't take much of a speed bump or a ramp. You can hear the air dam scraping on the bottom or rub the chin of the car. So we've long wanted to do this, and actually I'm a big defender of the transverse composite springs we've been using for years, and I know the media celebrating getting rid of the leaf springs. They're not leaf springs. In fact, if we could have done transverse composite springs on this car, we would have. We couldn't because the drive line is mounted so low, there's no cross-car path to put it. So we're essentially forced to go to coil-over shocks. But the good news is that let us put a relatively simple hydraulic lift under the front spring on the nose of the car that let us power that thing up about 2 inches. So that's another button that you hit right on the center console, and every time you hit that button, well, the first time you hit it at a certain location, a screen will pop up in the DIC saying, do you want to remember this? You just hit the button on the steering wheel and it remembers it forever. So every time you approach that obstacle, it'll automatically lift. So, you know, we announced we can... That's the reaction we got. So, you know, remembers 1,000 points and you can delete them anytime if you know you're not going to be back. And then it's also cool, it works up to 24 miles an hour. If you're coming in fast to an obstacle that you've previously remembered, it'll lift it, it'll start sooner. It'll say, oh, I'm approaching this GPS location, guy's not paying attention, he's coming in too fast. The car will say, uh-oh, we better get this nose up in the air. So it's smart enough to know when you're not paying attention. So, we announced our top speed of 194 miles an hour, but we didn't put out a video. So we're going to show you a video of that run, and it's going to start right now. So this is done in Papenburg, Germany. It's a level track. It's where we've done our top speed runs for many generations of car. And unlike a lot of manufacturers who go out and just run a straight line, and whatever the top speed they see on their instrumentation is the top speed they post. That's not really the right way to do it. We have always done it the right way, which means you do a flying mile, so you have to average the speed for an entire mile, and you have to do it in both directions to account for wind. Because typically what you see is a pretty different speed depending on which way you're going. So here we are, coming up to 194. And we're not showing you both directions, even though we could, but this is the first time, in my experience, we actually got 194 in both directions. Usually it's like 3 miles an hour high on one way and 3 miles an hour, and then you average them. And the videos we typically show that. For some reason, they were like dead calm at Papenburg this year, and so it was exactly the same speed, passing one way and the other. So if you watch the video, it's as usual, non-event, a couple of board development drivers cruising down the road at 194 miles an hour. It's just, another day at the office. The car's very easy to drive at speed. It feels extremely planted, and that's why the video is so boring. You don't see the guy wrestling around or trying to catch the car or anything. So we're very proud of the stability that we have in the car.
Z51 or standard?
That was the standard car. So the standard car is very slick, so that's the one we use for top speed runs. The top speed in Z51 is 184, so we trade off top speed for downforce. You'll see race car top speeds are not very high. It's because they want to keep the car planted on the ground.
I noticed it was in 6th gear, not
6th gear is the top speed gear. So I didn't talk about the DCT. We take advantage of the fact that we have 60% of weight on the back, use a very low first gear ratio, so that gets the car off the line and moving. It's largely responsible for 0 to 60 under 3 seconds. Then gears 2 through 6 are your track gears, and 6 goes all the way up to top speed. Then as we've done historically, our top gears are tall overdrive, so 7th and 8th are great for, street driving. So you quickly get up to low RPM, it's quiet, it's low mechanical stress, really good fuel economy. So we've applied that same kind of traditional Corvette philosophy to this blank sheet of paper DCT. So I think we got a few minutes for questions. Happy to take. Performance traction management. Oh, PTM. If you get Z51, you get performance traction management. Period. That's like it is today. It's not. Carlos can answer this one.
The magnetic ride and the performance traction management, so we call that V4, that comes together. So you have to get both together.
Sorry.
All right.
We should.
Okay.
I'm for it. Okay. Other questions? Right here.
The competition seat, does it have a provision for a submarine strap for a 5-point harness? And is there rear brake cooling?
There is rear brake cooling. We had this question yesterday about track belts. We don't put provisions in that are explicitly designed for track work. Our lawyers simply won't let us do that. We don't know what the aftermarket content's going to be. We can't stand behind what they're going to do. We can't take that liability. So we try to do the best we can to give them the best chance of providing really good accommodations for hardcore track work. But the answer is no, other than the sport seat has a notch in it, the way it's designed. If you look at it out there, there's a path to get the belt a good place to come up into your lap. Next door.
So for the fans of Corvette racing here, for Le Mans next year, will we see this mid-engine car for Le Mans, and will we see it in the accelerator yellow?
We'll be making an announcement shortly. All I can say.
Okay.
Back here.
It's just something about the electrical system being faster. Can you tell us a little bit more about the electrical system?
Sure. We're one one of the first users of a new electrical architecture that will be used across General Motors products. It is quite a bit faster, so speed of messaging much faster. The big part of it is cybersecurity, so every message is encoded, even though there's not been any high-profile hacks of publicly, vehicles. It's going to happen someday, and so the fact that cars are so connected, either through your cell phone or OnStar for us, we have to take precautions to make sure nobody can come in and tamper with your car. So that cybersecurity is a big part of it. And then we're also adding over-the-air, so we can download new calibrations into the car, improvements in the car over the air, which I think will be very helpful. Every time we introduce some new features, customers are always saying, well, can I get that in my current car? Usually the answer is no. With over-the-air updating, there'll be some stuff that we can actually make backwards compatible and help cars stay updated.
You're in the past tuners would mess around.
We got more questions.
Noise level, C7 versus C8 inside.
So that's going to be one of the things that's going to be most surprising to people. When you get in this car, you'll know in 100 yards it's a different kind of car. Having the rear tires so much farther rearward, and because sound pressure level, what you hear drops by the square of the distance, those big speakers, the big wide rear tires, are quite a bit farther away, so you actually start with less tire noise. And the fact that we wanted to isolate the passenger compartment from the accessory drive, which is only about 12 inches from you, so you've got the drive belt, the tensioners, the generator, the compressor, all of those are sitting right over your shoulder, and a lot of mid-engine cars traditionally kind of sound trashy, sound of crude, kind of race car-like. And we didn't want that experience. So that's why I was talking before about plumbing the intake noise around the side of the car and up towards the door, because we have a very well insulated bulkhead between the occupant compartment and the engine to take all that high frequency noise out. So this is far and away the quietest Corvette we've ever done. A lot of that road noise is taken right down.
And we've got that question a lot, both, I think there's a preconception about noise and heat. And everybody said it's both quieter and cooler than the previous car, which a lot of people, because we don't have the hot exhaust going through the tunnel anymore and things like that. So even when we were doing the cars, when we first got in the early cars, we were like, these are way too quiet. We got to make the exhaust louder.
So yeah, we've spent a lot of time taking the noise you don't want to hear and getting rid of that, but amping up the noise that you do want to hear. So that's fundamental to this architecture. Yes, right here.
When you're switching driver like you switch totally circular steering wheel, how is it going to be to do the ones that they're more
The corners.
geometries other than your square? You've got the U shape. How does that affect people that would transfer into that? When I get partway through, it's going to bother my turn.
I was totally with you. When we first started talking about even the original flat bottom wheel, I was like, wheels are meant to be round. Why would you ever make a wheel that wasn't round? And so actually what we did is when we first started talking about this squircle, they call it, kind of a square circle, there was a lot of us that were kind of skeptical that why do you want all those corners on the steering wheel? And so we actually used 3D printing. We printed some steering wheels and put them in a current Corvette, and we lived with them as daily drivers to see what it was like. And there's a little bit of adaptation, a little bit of a learning curve, but it's surprising how quick you get used to it. And those corners almost seem like handles. Like in typical turns, you grab a corner and you know exactly where the wheel is. And it's amazing the number of comfortable hand positions there are. If you're a 3 and 5 person or 3 and 9 person, you have a full rim to grab on. If you're more a 10 and 2 person, you have a full rim to grab on with nothing in your way, so you're not grabbing in a transition where the shape is transitioning. So I was a big skeptic early on, and I became convinced that not only was it just fine, it's going to be great.
And I would say the car in normal driving, the steering is so quick, you can keep your hands at 9 and 3 and anything but an extremely sharp turn, just driving the car around, you can do your F1 imitation. It's really actually a lot of fun.
Yes, back there.
Yes, the dent and cracked wheels, have you considered this in the C8? I mean, has there been some thought, as a daily driver, this is a concern for me.
Yes, so you're talking about, the question was for people listening outside, so have we tried to do something to improve the robustness of the wheels, the road wheels? You're talking about steering wheels, now we're talking about road wheels. And the answer is yes, even though we've historically designed wheels the same way to the same loads, we have seen an increase in the number of people bringing their cars in with a bent or a cracked wheel. And so yes, we increased the load. We came up with new testing actually. And if you look at the inside rim, there's actually a little more meat, so it's directionally incorrect for mass, unsprung weight, but it does make the wheel tougher and more robust. So, yes, right here. Question is, have we run the car at the Nürburgring? Yes, we have several times. We do development testing there on all our programs. Everybody's interested in the fast lap. That's the last thing we do. It's never been something we prioritize. They're also making it difficult to run fast laps. So we were there actually just this July to do our final tweaking and tuning. Actually, that's the top speed video that we just showed you while we were in Germany. We did that too. So we did get some good data. We're pretty happy with the car, our handles there, and we may publish a lap sometime. Yes.
So on my YouTube channel, I get the question, will chrome wheels come back?
Question is, will chrome wheels come back? Well, I'll never say never, but we do not have any plans right now to bring chrome wheels to come. How many people want chrome wheels? Let's see. How many people don't like it that these people want chrome wheels? Uh-oh. The tide is turning here.
I would say take a look at the car we have on display, the ceramic car, which has the ultra bright, polished, machined aluminum, and that's, I don't know if the request is specifically for chrome, but if the request is for a bright wheel, that's our brightest wheel. I think a lot of people like bright wheels, but we thought this is a more honest finish than the chrome plate things.
And the whole industry, honestly, is moving away from chrome, just from an environmental impact and other reasons. So we are too. Two more questions. Yes, right here.
Will 0 to 60 ever be released for the stock car?
Absolutely.
All the magazines.
Question is, will the 0 to 60 be released for the stock car? When we release our times, that's why we said 0 to 60 under 3. We want to test a bunch of different production spec cars before we make a claim. But we're doing both FE3 and FE1, and we'll publish those numbers probably in the not too distant future. I think the thing people are going to be most surprised about is how close they are. People are going to think, oh, they're bragging about C51, that's the fast one, the other one's going to be a lot slower. You'd be surprised how close they are. And last question, all the way back in the corner. Upside. So he's talking about Ackerman correction angle, so that's chassis calibration. Most of you know it as the chatter that you get when you're, especially at lower temperatures, when the tires have stick-slip properties that are very sensitive to that, especially on C51 and some of our up-level models. You feel that kind of chatter, the tires stick and slip as you go around a tight corner. That is gone. Okay, I think that's it. I'm sorry we have to cut it off. Thank you very much for coming.